Let us continue our work in Chapter 7 with Section 7.2, Operations with Matrices. Here are the learning objectives we plan to complete by the end of this section. First one is determine if two matrices are equal, be able to add, subtract, and multiply matrices by scalars, and then actually multiply matrices. There's a difference. We're going to see that. And then use matrix operations to model and solve real-world problems. So let's talk about sum, difference, and scalar product of matrices. All right, so we start off the definition as two m by n matrices are equal if and only if corresponding entries are equal. The fact that it says two m by n matrices are equal means that they must be the same dimension or size, or another word we used was order. So your matrices have to be the same size before you can consider them equal. So they're both the same size. Now they'll be equal if all the corresponding entries are equal. So there's our first operation. Not necessarily an operation, but our first definition. Okay, now to find the sum or difference, guess what it says? I have to have two m by n matrices. You know what that tells me? If I want to find the sum or difference, if I want to add or subtract two matrices, they must be the same size or dimension, or as we said earlier, order. So if they're the same size, then to add or subtract, or to find the sum or difference, I'm just going to add or subtract corresponding entries. This is easy stuff. Finally, scalar multiplication refers to multiplying a matrix by a constant. So in scalar multiplication, we're just multiplying every entry in that matrix by that scalar or that constant. Excuse me. So let's practice those operations. And if we can't perform the operation, we're just going to say doesn't exist or we can't perform. All right, so I've got a list of matrices here, and we want to find the first thing, which is A plus E. So notice matrix A is a 2 by 2 matrix, and matrix E is a 2 by 2 matrix. Okay, they're the same size. So that's a good thing because I can only add or subtract matrices that are the same size. So now I'm going to set it up. 2, 6, 0, negative 4. There's my first matrix. And I'm going to add it to matrix E, which is x minus 1, 6, z plus 3, and negative 4. So I want to add corresponding entries. So that means I'm going to add the 2 plus the x minus 1. Then I'm going to take the 6 and add it to the 6. I'll take the 0 and add it to the z plus 3. And I'll take the negative 4 and add it to a negative 4. Now I'm just going to clear this up, clean it up, perform the operation. So 2 plus x minus 1 will end up just being x plus 1. 6 plus 6, 12. 0 plus z plus 3 will just be a z plus 3. And negative 4 plus a negative 4 will be a negative 8. Notice both A and E were 2 by 2 matrices, and your result is going to be a 2 by 2 matrix. Just be careful with your arithmetic, otherwise it's a pretty easy operation. Let's look at number 2. I want to take matrix F and add it to matrix D. So matrix F is a 3 by 3 matrix, and matrix D is a 2 by 3 matrix. Guess what? We can't perform that operation because they're not the same size. So that was easy. So they must be the same size in order for us to perform that operation, to add or subtract. All right, let's look at number 3. It's saying 5 times the matrix C. Well, 5 is that scalar we were talking about. Okay, so I'm just going to take matrix C and multiply all those entries by 5. So what will this new matrix look like? 5 times 1 is 5. 5 times 2 is 10, and 5 times 0 is 0. There's a scalar multiplication. Okay, let's look at operation 4, problem 4. The operation I want to perform is 3b plus 2f. Here's my b, and it's a 3 by 3, and f is a 3 by 3, so yes, I can perform that operation. So let's multiply matrix B by 3, matrix F by 2, and let's add those corresponding entries. Excuse me. So here is what 3b is going to look like. Multiplying b times 3 would be 3, 0, 0, 0, 3, 0, 0, 0, 3. Matrix B with the 1s across the diagonal and 0s everywhere else. When I multiply it by 3, I basically just get 3s across the diagonal. Now let's take matrix F and multiply him by 2. So 2 times negative 1, that'd be a negative 2, 6, 12, 0, negative 6, 8, 2, 2, negative 4. Multiplying the whole matrix F by 2, basically just doubling it. All right, now let's perform that operation. Let's add corresponding entries. So 3 plus a negative 2 would be 1. 0 plus 6 would be 6. 0 plus 12 would be 12. 0 plus 0 would be 0. 3 plus a negative 6 would be negative 3. 0 plus 8 would be 8. 0 plus 2 would be 2. 0 plus 2 would be 2. 3 plus a negative 4 would be a negative 1. And notice the size of your answer is the size of the original matrices. Let's take a look at 5. It says we want to find the values of x and z if matrix A is equal to matrix E. So let me write down matrix A. And I'm going to set that equal to matrix E. Okay, so it's telling us suppose matrix A is equal to matrix E. That means corresponding entries are equal to each other. That means this entry of 2 must be equal to this entry of x minus 1. This entry of negative 4 must be equal to that entry of z plus 3. Excuse me, not z plus 3. Positions must be equal to, well, all right, let's back up. Z must be equal to x minus 1. 6 must be equal to 6. Got it. 0 must be equal to z plus 3. and -4 must be equal to -4. Got it. Okay, so notice the 6's are equal, the -4's are equal to each other. Now we just need to set 2 equal to x minus 1 and 0 equals z plus 3 in order to find the values of x and z. Well, when I solve this for x, I get x equal to 3 because I have to add 1 on the other side. And when I solve this one for z, I get z equal -3 because I have to subtract 3 on the other side. Sorry, I got twisted up on that one. Let's look at problem number 6. I want to find g minus 3 times a. Let's go back and look at our matrices. So I'm working with g and a. How big is g? G is a 2 by 2. A is a 2 by 2, so I can do this, I can perform this operation. So let me write down g, 340 -7. And we're going to subtract from it 3 times matrix A. So 3 times A would be 6, 18, 0, -12. I just took matrix A that was right here and multiplied it times 3. 3 times 2, 3 times 6, 3 times 0, 3 times -4. Now, let's go ahead and perform that operation. So it's just going to be entry for entry. 3 minus 6 is a -3. 4 minus 18 is a -14. 0 minus 0 is 0. And -7 minus a -12 will be -7 plus 12, which would be 5. And the result is a 2 by 2. Let's look at performing this last operation. I actually have a matrix equation that I want to solve for x. And the matrix equation states 4x plus 3a is equal to g. So if I want to solve this equation for x, I first need to subtract 3a on the other side. So I'll have a 4x equal g minus 3a. And to get rid of the 4 in the x, instead of saying divide both sides by 4, I'm going to multiply both sides by 1/4. It means the same thing, but in matrices, this will work a little bit better for us with respect to matrix operations. So multiplying a 1/4 times the 4 gets me my x. X stands alone. And so the answer is 1/4 times g minus 3a. Well, lucky for us, we found g minus 3a just a second ago, right here. So it's going to be 1/4 times this matrix, -3, -14, 0, and 5. And I'm out of room right now, but what I would do to finish this is I would multiply the 1/4 times the -3, and that would give me -3/4. The 1/4 times the -14 would give me -14/4. 1/4 times 0 would be 0. 1/4 times 5 would be 5/4. I'll wrap this video up here and then work on the next one shortly. But let me know if you have any questions.